Alright, here we are at the end of the 30 minutes. The array is showing 12.4 volts without the load of the ReVolt running on it. The battery itself is at 12.9. See no reason why we shouldn't go ahead and run it again, so we'll just simply do that. There we go. And while it's running, the array is pulling down to 12.2. Alright, we've got 5 minutes left. It's currently at 12.2 volts. Again, it'll probably slide back a little bit from that, just because, like I say, the process does put some charge into it. So we'll see in just a few minutes where it ends at and what it tests at, and then we're right now at 11.9 on the array, so we've probably got another run or two in the thing before we add another battery to it, and then maybe even another run. So we're making progress here. Again, this is an old battery, very old, and it might fail because of that, plus whatever abuse was put on it, which we don't really know. We're not going to cut it apart or MRI it or anything like that, so we'll see. Alright, so we finished up again, 12.1 on the ReVolt, and meter says, meter says, meter says 12.0, and now it's showing 115 cranking amps. So again, not a whole lot of increase in voltage in terms of state of charge, but you can see the amp capacity is going up pretty well. So we're making progress with this battery, and that's the important thing, because at a certain point we can put it in the array and use it. Okay, I'm going to go ahead and start it back up again. It's reading 12.1 on the array. We'll just keep running wave 3 on it. Not get too aggressive here. And we should have another 30 minutes of runtime here. Okay, we have about 5 minutes left, but we are down to 11.5 on the array. So I'm going to go ahead and tap this other battery in here. And now we're back up to 11.19. And let's see which one of these has the biggest impact. 11.1 or 11.9. Ah, it didn't drop at all. Did not drop at all. So it might be that one, 11.9. That one didn't drop at all either. 11.9. 11.9. 11.9. Wow. This guy seems to be holding up all of them right now. Alright, I'm just about done with another 30-minute cycle. Still at 12.2 volts. Okay, we finished another cycle here. The array is down to 12.1 volts. Let's go ahead and see where the battery's at now. 11.94 volts and 161 amps. Making some pretty big leaps there. All right, give it a shot again here. Hopefully it'll finish this cycle up. Same thing again, another 30 minutes. And now that it's under load, the array is still holding 11.9. Well, it's getting pretty dicey if we're going to make it here or not. The array is down to 11.4 volts. We still have 10 minutes to run. So we'll see. We may lose power before we get there. Just saying. See if we can get an idea which one is our lowest one here. We're going to use the clamp on DC amp meter here to see who's doing the most work. 1 amp on the one on the end here. 0.4 amps on the second one. 1.3 amps on the third one. 1.1 amps on the fourth one. And 1.2 amps on the fifth one. Definitely this one here at 0.4 amps is not giving us much. Let's have a look at this last battery sitting out here, see if there's anything on it that we can patch in. I don't think so. I think it was run down from yesterday and it didn't get put on the array for the charge, so oops. It's still got a little bit of capacity, so let's go ahead and change that other one out. I'm going to pause this so that it takes the load off of it for a minute. Did bump the array voltage up a little bit, so I think it's we're coming out ahead. We'll go ahead and continue. Yeah, we're now at 11.6, so that'll probably give us enough to finish out this last cycle without a crash. And unfortunately, I'm going into the weekend, so this is going to sit here without any activity on it for 2 days. I expect this battery is probably going to fall back quite a bit, which is unfortunate because I'd like to show how this thing really works when it's got a fair shot at it. But we'll keep it going. We'll keep it going. All right, 6 more minutes left. Alrighty, here we are, the last minute, and in fact done. So we've made it. Go ahead and disconnect this, but the grid was down to 11.2, and yeah, that's fine. So now we'll go ahead and take a measurement on the battery before we go into the weekend, and we'll see what we got. Reading 12.04 volts and 184 cranking amps. When we left yesterday, it was at 11.8 volts and 24 cranking amps. So it's come a long time, or a long distance today, and we'll see what kind of shape it's in on Monday. Everybody have a good weekend. Okay, it is Monday afternoon, actually, about noon or 1 o'clock. Let's see what kind of condition this battery's in after sitting all weekend long with no charge or anything on it. It's still alive enough to light up the meter. Here we go. Well, not too surprised. It's showing 9.87 volts with a 30 amp capacity. So it slid back quite a bit, but like I said, I'm not surprised. It only had, 3 30-minute treatments, looks like, or no. It's a total of 6 30-minute treatments so far, and then of course it didn't get far enough, so it slid back. But our array is charged up, and we're ready to run some more rounds on it. So let's get everything set back up and turn our inverter on. Disconnect our solar charge here. Okay, and we are running again off of inverter power here. We will hook up our ReVolt. Just going to record that, what it fell back to here. Was 9.87 after 2 days. 9.87 and 30 amp. Okay. ReVolt on. Okay, again the ReVolt is running off of the inverter now. Let's see, we've been running 30 minutes of wave 3. Okay, guess we'll go ahead and continue that. 30 minutes, wave 3. And away we go. And we'll check back with it again after it's finished this 30-minute pass and see where it's at. Okay, it has stopped. We'll take some readings on it now. Meter tangled up here. Well, that's a bit of an improvement. It's at 12.08 volts, and it now has 231 cranking amps, which is well above where it was before. So again, here we are on Friday. When we left, we were at 12.0, 184 cranking amps. Now it's showing 231, so it's made a pretty good leap there. Alright, and our array voltage is at 12.2. We certainly have one more run, maybe 2 more runs in there, so let's go ahead and do that. And away we go. We'll check back in 30 minutes. Okay, we've completed another lap. Grid voltage unloaded right now, or array voltage unloaded right now is at 12.0. So let's see where this battery sits. 12.0 and 262 amps. Making progress. And we'll run it again. Okay, and just for the record, so under load, the array is going down to 11.8 volts. So it's still got another lap or two left in it. We'll check it back in a little while. But do note that with this much capacity now on this battery, if we went ahead and tacked it into the array, it would provide more than enough capacity than what the existing batteries there have already. So if we have the capacity to charge it in that period of time between when we need it, then we all of a sudden have more capacity. And we can just simply replace one of these cells. We don't have to take them all away. So the only reason we're limited to that is just simply the number of cables we have here. But given that, we could technically add the capacity of these 5 batteries plus this to the farm at this point, and now we have a lot of amp hours adding up. And I just want to be clear, these amp readings on here, these are what's considered the cranking amps. These are not amp hour ratings. So the two are not that tightly coupled. In a battery with the same, everything else being the same, the comparison is relative to the actual capacity of the battery. But when you're talking about different batteries and different types, it really isn't. All it's showing is that we have improved plate area available. This capacity will go up. The internal resistance of the battery series resistance will go down as the plate capacity increases. In other words, as more of the plate becomes uncovered from the sulfation. All right, we'll let it run. Okay, we have finished up another cycle. The array is sitting at 11.5. So it's getting kind of close. Let's see what we've got here. Regular flooded. All right, now we're reading 11.96, 282 amp capacity. You might be wondering why the voltage isn't really going up. As we've said many times, the charging is a side effect of the process. It doesn't necessarily charge the batteries, but it's kind of inevitable through the course of it that they will get a charge, which is why after we're done treating them, again, we recommend you use a common charger to top off the charge. So I think at this point we're going to try to speed it up a little bit, but we might kill the array. We're going to move the waveform ahead on this next cycle here. 30 minutes. Go to wave 4. All right, now our array jumped immediately down to 11.0. So we're going to pause that. It's back up to 11.4. I'm not sure it'll finish at that. Okay, we'll go ahead and set it back to wave 3 then. Now it's down to 11.1. So it should make it another round. And when it's done with this cycle, I'm going to go ahead and put it on a charger, and hopefully it won't fall back. And we'll see what happens then. I'll tie it into the array to actually take a charge on. More than likely, you'll see a spark when we first connect it, because it's not going to be at the same potential as these other batteries, or it might be close. They seem to be floating around 12 volts. But you don't want to take a battery that's down to, say, 11.5 and hook it up to the array when it's charged to 13, for example. If it's a real high current differential there, you're going to see a pretty good spark, but they'll be close at this point. So we'll hook it in, and then we'll let the charger do the work on it and see if it'll stay in play with the game. Now again, the charger is to simulate a solar system, so what we're saying is that basically we're going to put it on the array, and then the solar system is going to provide its normal charge to the array like it normally would, except that this battery should benefit from that as well. So we'll cover that when it finishes this last cycle. All right, looks like the array is not going to make it. Got down to 10.5 and gave the warning. So we're going to go ahead and pull it off and attach it to the rest of the array like we talked about, so we can get a charge. I'm going to take the battery that was giving us the lowest reading, which was this one back here at 49 amps. I'm going to take him off, and we will hook this guy to the array through his wire set. Okay, this isn't a really safe position to be in with this. Let me get things rearranged here better. And you have to think about this and make sure that you don't set things up so one thing will fall across the other. Okay. Now, where'd that go? Go back here with this. And now we'll go ahead and hook up our solar array, pretend like we've had it. It's daylight now. We're going to go ahead and get some charge. And then tomorrow we'll check the battery and we'll see what the difference in capacity is after it's got a charge on it. Naturally it should have some more cranking amps as well, but we'll see whether it's a contributor or a lagger to the array, and get an idea of how much by putting some other loads on here that actually take more power, and see what kind of capacity we've got out of the array then. So again, let's look at this. We've got this flooded lead acid battery in parallel with these 4 other gel cells here, showing you that you can mix types if your voltages are fairly equal. Now these don't all have the same peak voltage for charging or bulk charging parameters, but through 80 to 85% of their charging, they are the same. And so we use the lowest common denominator. Since we've got gel cells in here, our charger is set to 12 voltage. That will charge the flooded just fine, just won't get it all the way to its tip-top capacity. And that's the way we'll run it. You know, it's fine. So we'll check this again tomorrow and go from there. All right, here we are back here, and we've completed a charge cycle. The array is at 13 volts. We're going to go ahead and look at the battery now. The big one. 483 amps capacity, 12.97 volts. And that is again by itself. You see it's isolated from the array. Now really the only remaining question is how long it will hold that charge. And the only way to really answer that is to leave it disconnected for a few days and see what the state of charge is after that period of time. Of course, all batteries are going to fall off over a period of time. They all have an internal discharge rate. But if it's too high, then it makes it unusable because then it's consuming too much energy just keeping it up. But at this point, the battery is indicating that it's got a lot of capacity, and we'll do some tests on it and get an idea of what it's capable of by itself and on the array as well. Okay, so our next step here is to try to build beyond the capacity of these little ones. And so I brought another return scrap battery in from the shop here. This is a 2013 battery. You'll see it in just a minute. And its originally open voltage was 6.2 volts. Under load is 0. Was low on water. Basically, it's a battery that should be scrapped, but we'll attempt to bring it back with the ReVolt. Now, on these combined batteries, so we should be able to run longer cycles on it, and that should speed up the recovery of it. So, this is the battery here. And it's an old Kirkland. Date code 1013 on it. It's not leaking, that's good. They did have to add water to it apparently, so that's all we know. We don't know how much. We'll go ahead and take a reading on it now just to confirm what's there. And yeah, it's too low for the meter to operate correctly. Actually get a look at what it really is. .1 volts. So pretty much what they read there, 6.2 is what they wrote, and I'm sure under load it's nothing. So we're going to go ahead and connect it to the ReVolt. And we're going to connect the ReVolt to the inverter. It is. Go ahead and turn the inverter on. We're going to hook this battery back up. It should have been hooked up already, but we did that test on it earlier. Okay, and we'll turn the ReVolt on. And we'll go ahead and try an entire, well, we need to check the shorts first here. So here's the ReVolt in the camera. Just barely. Let's come over here now a little bit.